So let's look at the definition. So the header file typically provides us with a declaration, and that is enough information for the compiler to allocate memory for an object of that type. That's exactly why we have that. And then the actual code that does the manipulation and all the initialization typically is in a separate file that colloquially we call the implementation file, but in terms of C++ it's actually called the definition. So, and then let's first look at the definition then of our default constructor. What I'll tell you now is saying that the constructor initializes an object's data member. It's only half of the story. We'll come back to that when we start talking about design by contract. It's technically more than that, and initialization of an object's data member can go horribly wrong. So in other words, you can have an incorrect constructor that initializes your object's data member if it just initializes it to the wrong values. As for the default constructor, I've already said that a default constructor can be called without arguments. However, by no means is it guaranteed that every class has a default constructor. So default constructors may not exist. As a matter of fact, you will find out relatively early on that it's actually preferable, especially when it comes to classes that are ultimately immutable, that default constructors do not make sense. So it's the vast majority of classes that you'll probably write will actually not have default constructors. And as I said, we're going to come back to that notion later on. But if you again think back to Python, you may remember that there are mutable and non-mutable classes out there, right? For instance, strings are non-mutable or immutable, and there are, even for containers, two different versions, with lists being mutable and tuples being immutable in Python. And this is for good reason, and it's tightly connected to the fact that you may not necessarily have default constructors for immutable objects. So, and then here, the first thing we typically include and have to include when we provide definitions for something we declared before is the actual file that provides the declaration, which happens here. And then we can include any other additional library files. In this particular case here, we're going to include the C++ version of the C library's math standard header. So you'll notice a couple of differences here. The first one is when we include our own declarations, we usually use quotes. When we include library headers, we usually use angle brackets, and the reason behind that is the way how the compiler is instructed to search for these particular files. So when I use quotes, the compiler looks into the current working directory to actually try to find the pointer.h, and only if it doesn't find it there, it actually goes to the library's paths and sees whether there is a file called point.h in your library path. When we request the inclusion of a standard library header, or any other library header for that matter, we use the angle brackets, and that actually bypasses the search in the current working directory and goes directly to the libraries. And we can actually modify how this works, and we're going to somewhat do that later on, how this works and how this is handled at compile time. Another notion here is that also quite often is omitted by books, especially if they're old, is the difference between standard C library headers and C++ library headers. So the CMath header, note there is no extension, is the C++ version of the math.h header from the C standard library, but it provides more services than that. Frankly, and actually, a C++ compiler is not even obliged by the C++ standard to provide you with a math.h version of that header. So, but what this does really is it takes the contents of the math.h header in C and then puts this into the std namespace for the standard library to avoid name clashes. If you include math.h, it provides everything in the global namespace, and this can become a problem for large systems because, for instance, especially when we talk about things like vectors, every one and their dog when it comes to libraries has their own version of a vector or matrix, and not polluting the global namespace and keeping everything into their own separate namespaces is something that is um, um, very, very important for large systems. So this is number one. Number two, also because of that, you will see that this particular file lacks the directive that usually says using namespace std, and throughout this class we're never going to use this because namespace pollution is a problem for large systems. So the using namespace std um, directive is something that is really hurtful, and it was always only ever meant as a transitional tool, and certainly if you just prefix all your names with the std : namespace resolution, it's just 5 characters more, and actually the most modern IDEs will automatically handle that for you. So, but that is why down here, when we actually use the sqrt from the CMath header, we actually prefix it with the std prefix. Another thing that many books get utterly wrong, and we're going to spend some more time on that as well, is how to properly initialize data members. And 99.9% of the time you should never use assignment in the constructor body to initialize a data member, but you should use initialization lists, as you can see down here. Again, here's the rationale also that makes it easier then to write those initialization lists by having the formal parameter and the actual data member have different names. So that really helps in this case. And as you see here then, most of the time for these easy cases, the constructor body is actually empty. And we're going to come back to why we use initialization lists, because it's safer, it's more rigorous, and it can be a lot faster.